right, so the topic today is the agentic AI platform. So the way I want to kind of talk about it is I'll take a use case, which is a customer support use case, and sort of walk through the architecture along with the use case. So it helps kind of reinforce the concepts in the architecture. So I'm guessing nobody needs introduction to what Uber does. All of you are familiar. I'm sure you're taking rides on Uber. And no, you don't even need introduction to customer support. So it's a very familiar space. I'm sure at some point you all talked to customer support, used it across Uber or otherwise as well. So Uber support, just in one line, we handle millions of support interactions a month across 10,000 cities, 50 plus languages. Millions of support interactions. I mean support interactions. There are not so many bugs and issues that we see, thankfully. These are interactions where people come to say, how do I do this? How do I do that? Help me troubleshoot. All of that. They're not just issues. And 50 plus languages, that is just the official languages. We do see a lot of Kanglish, English, transliteration, all of that. I know LLMs can handle that, but there are certain locale nuances also that we kind of take care of it. Right? What helps us achieve all of this? One other nuance I want to talk about is when we talk about Uber, I know a lot of you here have used the rides product, but there is a lot more than that, and a lot of that is available outside India. Like, there are multiple personas that we end up dealing with. You could be a rider, driver, eater. You could be a restaurant. You could be a grocery store owner. You could be a shopper picking up items. You could be what we call the picker. So there are multiple personas that we deal with when it comes to customer support, and our platform has to kind of cater to all those use cases. And they come with different issues, different questions, different problems. Right? One other thing that I've not put here is also autonomous vehicles. Here I can actually say a persona, which eventually, I'm talking to a human, whether it's an organization or a driver or rider. But what do we do with autonomous vehicles? Who are we talking to? Right? Even there, they need support. So how do we kind of model all of that? So that's the mix of all the problems that we see. All right. I think Jairaj mentioned this. What you see here is just a help interaction, which is a conversational agent. The expectation is, user query goes into a magic hat that uses LLM. Out comes your response, which is accurate, beautiful, empathetic, everything solving the user's problem. But that's not the reality. We all know that. There's a lot that happens other than that LLM that is sitting in there. What the LLM helps is, of course, understand what the user is saying. If you kind of break it down, right? These are the three major things that happen. Understand what the user is saying, investigate, if required, about the problem itself, and finally respond or resolve the user's problem. LLM is not doing it all by itself. I think even Sachit said that it's 20% what it does, and there's a lot of 80% that goes on behind it. And to just reinforce Jairaj's point, we pretty much started on productionizing some of this almost a year ago. So it took us a year to be able to say that we have something live and running in production, enough use cases that we can talk about. So it is a long journey. So we'll kind of open up and see what is inside that magic hat, again, at a very high level, whatever we can cover in 20 minutes. At the top, we have a bunch of our surfaces, whether user can come through an in-app surface, they can come through web, we even have agent tools, human support agent tools. And there are multiple surfaces that we interact with. The second layer is what we call the channel infra or orchestration. When I say channel, it means people can talk to us on phone, they can talk to us on voice notes, WhatsApp, most of it is in-app chat. So all of these are different channel infra that we kind of collect. And eventually, it comes into the conversational agent platform. And that will be the focus of our talk today. And the conversational agent platform, just walk you through. The first thing on the top we have is a planner. Basically, it plans out and says what needs to be done with this particular user query. Who all do I need to call? It's sort of an orchestrator, right? It finds out, OK, what all do I need to do to be able to solve this user's issue? So underneath that is a bunch of AI agents that we have, which use tools and knowledge to be able to give answers. And at the bottom, again, although it's at the bottom, one of the very key pieces is the infra itself. I think many speakers spoke about the infra. It helps us with monitoring, logging, discovery of agents, hosting agents, deployment of agents, and a bunch of things like that. On the other side is the key capabilities which we kind of use across all agents, which is the evaluation framework, AI guardrails, and testing and simulations. So I'll go into each of these blocks in a little bit of a detail. Okay, so first thing is you need that planner. I mean, that's what we figured out. Initially, we thought we can just have multiple agents kind of answer, but then we realized that we absolutely need some kind of an orchestrator and a planner. What does a planner do? Let's say I come with I'm a rider. I come to Uber customer support and say, start with a greeting. Hi, how are you? I have a question. It's a very generic thing. It's a small talk. We engage in small talk. The planner then figures out, first thing it does, it actually fans out a bunch of requests to what we call the analysis nodes. Once the user has reached out, I need to collect data. I need to understand what the user is saying. So we do a bunch of things like detect the intent, detect safety, because safety handling is very different. If I'm in trouble, I need to be able to get to a human very quickly and not be fronted with an automation. Detect the locale, or fetch the context, like I said, where is the user coming from, what are the previous trips that the user has had, is he or she talking about a particular trip. All of the data collection happens. That happens in parallel, so it's a sort of a fan out. Once that it collects all that information, and then it sends out requests to what we call the resolution nodes. So it figures out, okay, given this is the intent, which is the right set of resolution nodes that I can talk to. For example, I started with a small talk. With the small talk, okay, I don't need to there's nothing fancy here. I can just respond to that small talk, which could again be through an LLM. It doesn't need to be a fancy agent. So it does that. Or let's say it does respond with a small talk. The next step, the user says, okay, you know what? You charge me a cancellation fee, and I think it is unfair. Right? The next question again, then it goes to the planning node. It says, okay, now the user is actually talking about a particular problem. I probably need to call a specific agent which deals with cancellations or issue resolutions. Let me put it that way. So it then calls the resolution nodes. And let's say the resolution node comes back with it and says, okay, yes, there was a charge, but we've already refunded the charge. And that's the resolution that's already been provided. That response comes back to the planning node. And the planning node says, okay, I see that the refund has happened, but user still seems to have a query about it, which means maybe I need to add additional context. In the sense saying that you may not have seen the money, it will come to you in 3 to 5 business days. Additional information like that. So that request actually gets fanned out to the content agent also. So it kind of merges the responses of multiple agents or resolution nodes together before sending out a response, eventual response. That eventual response, there is a response generator which kind of merges all these responses together and sends it back to the planning node, which responds back. Since planning node is also sitting in the center, it also does a bunch of things like guardrails, detecting for prompt injection, and also both input and output side of detections, it does that. So that's the planner. Now, after the planner, the second layer that we saw was this. So we do have a bunch of what we call the specialist agents. So what these specialist agents do, this is one of the examples of a specialist agent. This specialist agent takes in a business policy, takes in the conversation history sent by the planner, takes in the context, again, whatever the planner has built, and sends it down to an agent. So in this case, I'll just give you an example of what a business policy and why we need it. So the business policy is mostly, let's take the example of a eater, although we don't have it here, or a grocery item. I could come to you and say, hey, I was missing a bunch of items. I need refund for that. Right now, what do you do with missing items or spoiled food or something else? The business policy dictates what is the action that needs to be taken, right? So, or things like, my order was delayed. Based on how much it is delayed, I might do different actions. So the business policy really dictates that. The way we intake the business policy is textual or graphical. We actually support both. But eventually, we still convert it into sort of a graph. So, and we call each of the nodes routines. And it's sort of a self-contained either decision, action, or those kind of nodes. And this particular agent takes that graph in and runs it through. The first thing it does is what we call the routine selector. The routine selector will say, okay, given the context, do I need to traverse the whole graph, or can I jump to the right portion of the graph? So it does that. It basically says, okay, I don't need to run through the whole graph. Based on the conversation history, we've already resolved a few things. I'm going to jump to that particular portion of the graph. Once it does that, there are a bunch of executors First thing is a decision node, where user is claiming a certain thing. Now I need to validate whether that is right or not. User might be claiming that the driver never came, hence I had to cancel, so you need to refund my money. Now we need to verify that claim through data points. We need to verify that claim that where the driver was, whether he was at the pickup point or not. That really comes from the data. So the decision routine takes in the user's utterance, adds data on top of it, and comes to a decision as to what the next step is. That's the routine executor. So the decision routine executor. Then once we do that, we need to take the actual action, that's action executor, and then finally respond back with a right response. And that part, and all of where I've marked with LLMs, these use LLMs to kind of use a reflection pattern. I'm sure a lot of you are familiar with it. So what it does is it comes up with a response, whether it's a decision outcome or a final response to the user, it comes up with it. Then it kind of reflects on that response and says, am I doing the right thing? So that kind of goes through that loop. So that's the reflection pattern, and that's primarily from LangGraph, the image that you see there. So it goes through this loop, tries to reflect on its response, improves that response before finally sending it out. On the decision side, what is it really reflecting on? It is basically reflecting on whether I am policy adherent. So we have a metric, and we say that whatever the decision is outcoming from the model, is it actually adherent to the policy that has been outlined overall? Is it complying to the policy guidelines? So that is what it is actually optimizing in the reflection. On the response part, it is optimizing for any policy leaks. For example, you've been, let's say I'm an eater, and I've been constantly complaining about missing items or spoiled items last week every day, right? And now we have rules to check for that. We do check and say, this is potentially fraud. We don't want to give out money. I mean, that's our policy, right? But I can't say that to the user on his face. I mean, we might feel it, but we don't say it, right? We can't say, oh, we think you're potentially fraudulent, so I'm not going to give you money. So there's a policy leak. And of course, people don't want to hear it. So what we do there is basically put this through the loop and make sure these policy leaks don't happen. Where when we are responding, we want to make sure that we're still not leaking some internal portions of the policies. And the response routine executor is really optimized for that. So this is one of the specialist agents that we have. There are a few more like this, but this is probably the most complex one that we have. And there are a bunch of other vendors also that do this, like Decagon and all of that. We've talked to it. We also talked to OpenAI. Most of them kind of follow a similar model and similar architecture. And this has kind of come about through the collaboration through them. So that is one of the specialist agents. Now we have a bunch of generalists too. What do I mean by that? So we have a bunch of general agents which can do a summarization job, which can do a question answering. And I talked about guardrails, right? Things like, what are the safety checks that we have? What does our communication policy say? What is our legal compliance like? Is our response sticking to that? So these are a bunch of general agents that we have built, which can pretty much take in any sort of an input, again, a set of parameters, and be able to give out a response. So the planner is really orchestrating through these multiple agents, both specialists and generalists. The next one, while we talked about the various agents that we have, the other important piece we feel is the evals, right? I think a lot of people talked about it. And Amod was also saying that one of the fault lines is non-determinism. So if you were to just throw a bunch of data and the policy at an LLM without any of this framework, a lot of people will be claiming refunds, and you'd all be having free rides or free orders or free groceries. And we don't want to be losing money. So we do have evals. We do have, and like this one depicts, right? I kind of think of it as layers. If you think of an onion, it's like layers of that onion. At the innermost part, you see the models. And then what you want from the model, you have prompts to get output from the model, asking it to do whatever it's supposed to do. The models and prompts, we kind of test it during unit testing and development itself. And the framework we use is prompt food. There are a few other frameworks that are available, but we sort of have adopted prompt food to some extent. And the test data here is really manually curated, whoever is developing, just it's more like a unit test. You have your test data, you run it, etc. And what are we evaluating here is primarily for model quality and prompt quality. So the reason I'm talking about this onion and layers of it is when people think about evals, they only think about LLMs as judges. But I just want to break that myth that you have to introduce testing at every layer. I mean, this is no different from what we do today as engineers, right? Every layer needs to be tested and it needs to be robust before we claim victory. So the second layer is really the GenAI agents layer. Agents obviously have a bunch of prompt chaining that they can do, tools, function calling, all of that kind of coming together. Now, when we test that, that is where we actually apply the evals in the true sense. Our evals is also broken up as primarily pre-launch. That is, what are the evals that we do before we launch something? Or it's sort of like your integration testing that you run for every, before every deployment. We also have what we call the post-launch evals. And this is where the LLM as a judge is used, where in pre-launch, we do have a test set. So we can run against the test set and do a comparison. This is like your assert, typical assert, right? I have test data, evals data set. I compare it against what is expected. I'm done. Post-launch is the harder part, where there's no one to tell you what was expected. No one is telling you what is expected. So you kind of use another set of LLMs to decide what is expected. And then you come up with your metrics. And we also augment it with human evaluators. That I don't think, at least this is a problem industry-wide, where they're struggling to get auto LLM as judges to a level beyond 80% accuracy. So there are still inaccuracies that the judges face. So we do augment a lot of this with human evals. We do audits, we do sampling, a bunch of that, so that we can send some of these to the human evaluators. The framework that here we use is a bunch of homegrown frameworks that we have to simulate a conversation. It's what we call the dueling bots. I pretend like I'm an eater, or rather the bot pretends like it's an eater and talks to our system, and it gets a response. So, and then there is, of course, the framework itself for the pipeline. And then we do have our own labeling framework. This is, again, public, called the data labeling framework, where we have human evaluators evaluate all of this for us. The test data set, like I think already talked about, for pre-launch we use golden data set. And then for for post-launch, of course, we have the production logs. Finally, again, evaluation is on, we have our own rubric. For example, the policy adherent agent that I talked about, we measure it on adherence rate. Is it adhering to the policy? This is outside the response quality itself, right? And then finally, the orchestration and the user interaction layer that we saw on the top, that also needs testing, not to discount that. On that, we have the standard end-to-end testing frameworks and UAT and all of that. OK, the final layer is the infra. I don't think I'll stress too much. We have heard a lot about this today, but that is definitely one of the key things. Just want to highlight a few things here, just in terms of maybe curiosity. The SDK that we use, or the framework that we use, is LangFX today. We do use agent-to-agent protocols for the agents to talk to each other. And the model gateway. The model gateway is one place where it's sort of like a router, right? People talked about optimizing for cost, accuracy, all of that. Now, this gateway, what it does, we can tell which model to use. It will talk to that vendor or even an in-house model and give us responses from that. It also does things like it actually invokes the PIR redaction before, if we are sending it out to an outside vendor. It does that. It also does request response caching. I know a lot of you have heard of prompt caching, which OpenAI and a few other vendors already do that. This is even one layer before that, where we don't even send the request to the vendors. So we have kind of optimized some of that within our model gateway itself, so we can talk to multiple vendors seamlessly and optimize for cost, accuracy, or latencies. We do have our own MCP servers and gateways to talk to the underlying services and data. The other agent services, I think, similar to other agent platforms that people have been talking about. It helps us with the monitoring, CI/CD, logging, tracing, operability, whole suite of operability. That is trick 5. And finally, on the learnings itself, Think we've heard this through the day. So just reiterating that, we are using deterministic flows wherever possible, making deterministic decisions wherever possible, and using the LLMs just for the power of it, to understand what the user is saying, rather than to arrive at a decision. The data, arriving at a decision is mostly powered by a lot of data, rather than just what the user claimed. So that has helped us a lot. Otherwise, I don't think we could get to the accuracies where we can productionize it at all. Without that, I don't think we could be there. Second, stressing more and more, because we are in this realm of non-determinism, evals is most critical piece. I would actually say start building evals first. That was one learning that we had. We actually started out a little late on evals while we had built this, and we had to kind of gate on it. We had to sit there and say, wait, okay, until this is evaluated, we cannot release. Or until human evaluators finish their job, we can't launch further. So things like that. So start early on evals. I mean, that is where you should, it's more like test-driven testing. I mean, it's the same philosophy. It's an evolving industry. There's a new framework. There's a new model. Everything, every other day. So we have learned to build our own abstractions on top of it. So we don't have to kind of change every layer every time we adopt a new framework. Right? As an example, I did mention the A to A protocol, agent to agent protocol that we use. And that is basically, for example, we are using LangFX now, or LangGraph now, but eventually we might move to AutoGen. If I were married to LangGraph and LangChain, I don't think we would be able to make that shift sooner, and you'd be migrating forever. So that is why we have adopted all these abstraction layers to make sure that I can change things underneath without affecting other consumers or callers. Yeah, this one I think you all know. There's no one-size-fits-all model, so we do use a bouquet of model based on use case and all of that. The fifth learning was also, we've learned that the APIs, no matter how popular the vendor is, including OpenAI, they are not fully reliable. They never guarantee SLAs. What they call is SLOs. We'll try our best. I mean, that's the best they can do. I mean, that's the guarantee you'll get today. So we have had outages, we've had degradations, all of that, right? So now we've learned to live with it. So what do? We bake in like model fallbacks. I can't invoke OpenAI models, I'm going to fall back on something else. And even experience fallbacks. Oh, let's say I see failures, I want to maybe quickly hand off to agents so our customers are not impacted. So where we are today, almost on a monthly basis, we see outages, degradations. So we're kind of now preparing for that in terms of baking in some of these. Yeah, that is it. I'm actually 2 minutes early. I saved you all time.